Hello everyone. In this video, I'm going to talk about how to calculate empirical and molecular formulas. Before working on the problems, I'm going to remind you empirical formulas and molecular formula definitions. In other video, I already reviewed definition for each type of formulas. I already talked about the similarity and differences between each of them. But in this video, I'm gonna focus on calculation. To remind you, empirical formula is one of the simplest possible formulas in the chemistry. In this formula, you may find type of atoms as well as simplest ratio of atoms in the formula. As you see here, it says percent composition can be used to calculate empirical formula. So one of the applications, one of the uses of percent composition is determination of empirical formula. Molecular formula is going to be related to empirical formula. In this example, I'm gonna share with you C6H12O6. Molecular formula is C6H12O6 and empirical formula can be reported by simplest ratio of atoms. If you divide by 6, you find empirical formula CH2O. You divide it by 6. 6 in this example is a factor, is going to relate empirical formula to molecular formula or vice versa. So in this video, I'm going to show you how to calculate empirical formula, and whenever you have empirical formula, how to calculate molecular formula. So in this video, we are going to address two types of questions: how to calculate empirical and how to calculate molecular formulas. First, let me work on empirical formula calculation. We mostly have questions like this. Calculate the empirical formula for a compound with this information. In this example, you have two elements. One element hydrogen, another one oxygen. It means we know only these two types of elements available in this compound. So one of the definition for empirical formula, one part, it was type of elements. And the second part, it was simplest ratio between elements. So right now, I'm gonna know how to find the simplest ratio of these two atoms, hydrogen and oxygen. It says this number and this number in percent. So whenever we have percent, we can assume that we have 100 grams of the compounds, and in this example 11.19 grams hydrogen and 88.79 grams oxygen. So look here, if you divide 11.19 grams by 100 grams, you find the percentage. So percentage can be easily used to consider for grams. So we assume that in this compound, in 100 grams of this compound, 11.19 grams hydrogen, and the rest of that we have oxygen. So the first step, if you have the percentage, you can easily convert that one to grams. So you don't need to be worried. So we are going to convert that one to grams. The second step, whenever we are going to work on the empirical formula calculation, we need to find the simplest ratio of atoms. So SI unit of quantity in the chemistry is mole. So we need to convert grams to mole. So if we have this information, we need to convert them to mole. How to convert grams to mole? I'm sure that you are going to use molar mass. So you need to look at the periodic table and find atomic mass of each element, then convert to moles. Let me show you the calculation we have here. I'm going to convert grams to moles. 11.19 grams hydrogen. I'm going to use the periodic table. My periodic table, in the periodic table I use, we have this molar mass for hydrogen, 1.008 grams. So I'm gonna cancel out grams and I calculate moles of hydrogen. Same for oxygen. I'm gonna use molar mass of oxygen and convert that one to moles. So guys, I completed this step. I converted grams to moles. So we have moles hydrogen, moles oxygen. Empirical formula, it gives us simplest ratio of atoms as well as type of elements. So we have type of elements right now. I'm going to calculate simplest ratio of atoms. So to do this, you are going to divide by a smallest mole number. So whenever you calculate moles of elements, you need to divide by a smallest mole number. I say smallest because for some examples, we have more than two types of elements. In this example, you need to look at the numbers and see which one is smaller and divide by a smaller number. So at this time, in this step, we are going to find the simplest ratio of elements. So I divide the numbers by a smallest mole number. I divide by 5.549 moles oxygen. So if you do that, so always for one of the elements you get 1, for another one you may get another number. So it looks the relationship between oxygen and hydrogen, and oxygen is here. Number of oxygen, and it gives us number of hydrogen. So whenever I'm going to write empirical formula, I'm going to write H2O. So because this number represent hydrogen, this number represent oxygen. Let me have a quick review one more time. So whenever we are going to work on your problems, if you have percentage, easily convert to grams. So you just need to cross the percent mark and write grams. Then convert grams to moles by using molar mass. And whenever you have moles, you just need to divide by a smallest mole number to find the ratio of the atoms. So let me work on another example. We have this question. It says calculate empirical formula when we have these elements with this percentage. So I may ask you to please pause this video, solve this problem, and back here and see your answer is same like me or not. Right now, I'm going to talk about the formula. In the formula, we have KCO. We prefer to keep ordering of the elements. If it says potassium at the beginning, so absolutely potassium should be at the beginning of the formula. Then carbon, at the end oxygen. Empirical formula. So if we have percentage, you can easily consider grams. So let me cross that one. It looks we have grams. Next step, we need to convert grams to moles. So you need to use the periodic table of elements. So let me solve that one. If we have grams, I use the molar mass of the potassium. So I convert that one to moles. So same for carbon and oxygen. At the end, we have moles of each one. Right now, I have to divide by a smallest mole number. Whenever you have moles of each one, so you need to see which one has the smallest mole number, divide by that one. In this scenario, in this example, carbon has a smallest mole number. So I have to divide everything by this number. So if you do that, you get like this one. So it gives us the number of potassium, number of carbon, and number of oxygen. As you see here, the formula is going to be K2CO3. So we can easily call that one potassium carbonate. But please understand, if we have multiple choice question, you can easily eliminate B because B is not empirical formula, is not reported in simplest ratio because we have these numbers. So you need to divide by 2. So you need to divide by 2. So if you look at the multiple choice question, some options you can easily eliminate that one and work on the some other options. And finally, this is another example. So I wanted to share with you this example to make sure you understand. When we say percent composition, we may work in the lab, we may do some experiments and calculate the percent composition of elements. Then when we have the percent composition of elements, you can easily calculate the empirical formula. So when we are going to discover some new substances, whenever you are going to synthesize some new compounds, we are going to do same procedure in real chemistry world. So we have like this information. I may ask you to watch this video as one reference and you may use that one for any other examples for empirical formula. In this example, mass percent composition given, so I have to consider percentage as gram, so I convert grams to moles for any elements here. So we have like this one. Right now, I'm going to divide mole numbers by a small number. So I'm gonna divide by a small number. Carbon, hydrogen, oxygen, I divide by a small number. And I will find like this. Please understand, whenever we have like this number, 2.25, so you cannot run this number to 2 or to another number like 3. Whenever we have a decimal part of our number like 0.25 or 0.50, 0.75, or any numbers like this, we prefer to multiply by an integer number to get a whole number. So in this scenario, if I multiply all numbers by 4, if I multiply all numbers by 4, I can find C9H8O4. Right now, it gives us the empirical formula of this medication. Why do we need to multiply by 4? Because I'm gonna convert this number to a whole number. If your number is 2.99 or 2.87 or something like that, you can absolutely run this number to 3. But whenever our threshold is 2.75, for example, so you need to multiply the numbers by one number to get a whole number. So to do this, I'm going to multiply by 1, no change, multiply by 2, so it's going to give it me 5.50. So let me quickly report that one, 5.50. If I multiply by 3, it gives me 8.25. And if I multiply by 4, it gives me 11. So it looks I may use this number to apply for all of the subscript here. So I multiply all of the numbers by 4. In this example, 2.25, I multiply by 4 to get that one. If we have, like, for example, 2.5, 3.5, or something like this, so you just need to multiply by 1, 3.50, multiply by 2, 7.00. So 7 is a whole number. So you just need to do that. it doesn't make any big deal if you are going to consider some different numbers to multiply that one, because you are going to make an integer or whole number. So whenever you have a decimal number like 50, you multiply by 2. If you have 0.25, you multiply by 4. So they are something you should consider if we have like this number. But most of our examples, like the previous example I used here in our class, so in the video, in the first two examples, so you don't need to multiply that one and you can easily report. Another question that we are going to address in this video, how to calculate molecular formula from the empirical formula. When we have molecular formula, please understand another term we use for molecular formula is real formula. And we most likely prefer to use real formula or molecular formula because it gives us not only type of elements, type of atoms, but also it gives us exact number of atoms as well. So whenever we are going to solve our problems to find the molecular formula, please understand always we have molar mass of real formula. This information always given to us. So you don't need to be worried about this. This information always given. And you need to calculate molar mass of empirical formula, plugging in the equation. And you may find n the number of empirical units in molecular formula. So I'm going to rearrange this equation and I write molecular formula is empirical formula that is going to be repeated n times. So we are going to find n. To find n, molecular formula mass divided by empirical formula mass, and we will find n. Let me work on a couple examples here. Question says we have a compound with this empirical formula. Empirical formula is this one. And we have mass of molecular formula. So this is the molar mass of molecular formula. So you are going to say N is molecular formula over empirical formula. So you need to write mass for each one. Molecular formula mass is given 32.05 grams. How about empirical formula? So you just need to calculate mass of this empirical formula. Nitrogen 14, hydrogen 1. So we have two hydrogens, I multiply by 2. So almost 16. So grams. So if you calculate that one, it gives you approximately 2. So N is 2. Molecular formula is empirical formula that will be repeated n times. So it means empirical formula NH2 can be repeated 2 times. So we are going to have N2H4. This is the molecular formula. Let me double check. It has type of elements. It has exact number of atoms. If I divide by 2, it gives us this empirical formula NH2. So it looks we solve our problem correctly. So let me show you the correct answer for this question. So molar mass of real formula divided by mass of empirical formula. So I use the information of the periodic table with the enough accuracy, so you may find the number is 2. So you just need to call that N2H4 is the molecular formula in this example. How about this one? Please think about it. I'm sure you can easily solve this one. Question says, what is the molecular formula if we have this info? Empirical formula, and we have molar mass of molecular formula. If you plug in the equation, you can easily get B as the correct answer. So mass of molecular formula divided by mass of empirical formula. So the number is 2. So this factor, it means applied for empirical formula to calculate the molecular formula. Hope these 4 examples, 2 examples for empirical formula and 2 examples for molecular formula, help you to understand the relationship between them. And also I give it you one specific example for empirical formula for the aspirin medication to make sure if we have some decimal numbers that we cannot round, so how to apply the numbers to make a real integer whole number for simplest ratio of atoms. Hope this video helps you to understand these concepts. Thank you for watching this video.